This is the 2016 map. As usual, there are a series of folds, some faults, a nonconformity and 2 intrusions in this particular question. So what we've got to do is interpret some of the geological features we're going to come across in the geological section. So one of the first things that we can see as a dominant feature is the unconformity, which is the base of rock unit D, which cuts all the way across the map. Let's mark that one in first. It cuts across the intrusion, F2, the series of folds which are below it. But if we look above the rock unit D and rock unit what's that one? C, which is above it, sorry, rock unit G, which is above it, there are a series of folds in there as well. How do I know? Well, if we look at the dip direction to around Y, the rock unit D is dipping towards Y, towards the east, whereas over towards X, it's changed dip direction, it's now towards X. So somewhere in the middle here, we've got a fold with equal dips. So we have an antiform actually within our unconformity itself. So once the unconformity is formed, there's been a period of folding that's created that particular feature. Now we've also got a Pluton directly below the unconformity, and it's got a metamorphic aureole around it as well. And if we look at this area up here, we can actually see that it's younger than F2. How do I know? Well, the metamorphic aureole hasn't been displaced. If it had been displaced, very much like the folds are here, we could say that the Pluton was there before F2, but it hasn't, therefore it's younger than F2. Okay, so we've got a fold, well, a series of folds below the Pluton. We can see that rock unit B, this dark grey layer, has been repeated several times, and that's going to be one of the key things that we're going to use to identify where the APTs are. So the white layer C is in the centre of the fold. This is where the APT is going to be. Rock unit B is repeated several times on either side. So one APT is going to be in the middle. We've got a vertical limb and one that's dipping 40 degrees towards Y. So we've got a fold axis here. We've got limbs of unequal dip. Converging, so we've got a synform in that area. Rock unit A is not repeated, but the others are on either side, so we have another APT in here. Even though these sort of dip arrows are not unsymmetrical about the APT, we can use that to inform where it's going to be and what type of fold it is. So we have another APT in the middle here, which is an antiform. Notice the outcrop width of rock unit B changes, and that tells us that we have unequal dip. The narrower it is, the steeper the incline. So this side here is more steeply inclined compared to this one. So another one in before we get to F2. Dip's going this way, and we've got a vertical dip on our limb here, so we must have a synform in that area here. And this fold is the same on this side, so our synform is there. Notice the APT is being displaced. Likewise on this section we'll have another antiform in here. It is now going to be going through these particular locations. There, it's displaced down here, but it's not displaced on that fault. I'll explain that in another video clip later. Okay, so we identified all the folds, or the fold APTs. I've transferred the information that I require onto my scrap bit of paper. I need to make some decisions now as to how I'm going to construct the cross section, making decisions in terms of how I'm going to display various different layers, the relationships between them, etc. So, well, the first thing that I need to decide is which is the youngest boundary layer that I'm going to put in, and that's relatively straightforward. It is the layers above the unconformity. So I'm going to mark in rock unit D, but I must remember that I've got to show a fold in that particular boundary because of the diverging dip directions as displayed with the map. After that, I know that Pluton came next because the metamorphic aureole isn't displaced by F2. So I'm going to put in rock unit E, which is the Pluton, and its associated aureole. I may put the aureole just as fraction later once I put all the other layers in. Then F2, and then the folded layers afterwards. Now I need to make a decision on the Pluton. It's a little bit unusual in that even though it's on X, the Pluton itself is curved around in this direction. So on our cross section, all this area here is going to be a Pluton, and it's going to hide all these layers which are situated below it. Think of it as being a bit like a balloon, and it's curved around the edges. It's dipping outwards there, so it's going to block all the layers underneath it. I must show that it's discordant to the other layers, so this boundary over here is going to be helpful to show that, and it's a large area within the cross section itself. So that's a little bit different to what we've had to do before. So I've got my layers, the order in which I'm going to construct it. Let's do it. Okay, so this is the cross section itself. We can see the examiners have given us some information. They've given us the tilt of F2. They've also told us the top of rock unit B or the base of rock unit C, very close to the fault itself. Otherwise there's no other way of working out where the boundary would sit along the fault itself. So the first layer that we're going to put in is the base, well, the unconformity, the base of rock unit B. We know that on either side of the cross section we have a folded unconformity. We know that this boundary over here is dipping 10 degrees towards Y and 10 degrees towards X over here. So let's put that one in first, because this layer cuts across every single feature on the map. Again, we don't know how far they're going to meet, so I'm just going to put a certain distance, but not too far over, until I know where things are going to be. Just off the map there. Okay, this goes up. So we've got rock unit D on either side. Fold axis, we know that we've got equal dip, so we can draw in a vertical fold axis here. Notice I've stopped it to the unconformity, it doesn't go any further above that particular point. Okay, so I've marked in D. The next one is the metamorphic aureole. So let's mark in where the boundary would be on here. So there's the boundary. Okay, let's go back to the map just to double check the relationships between the layers. So there is the Pluton. There's the boundary I just marked on. So all the way, even underneath the unconformity at position X, we have rock unit E. So I'm going to draw a boundary from this particular point, tilted towards Y at a steep angle, almost vertical, to demonstrate that all this is the Pluton there. Okay, and I'm going to do that sort of angle, and I know it goes up to the unconformity and it comes down to there. Okay, so all this is rock unit E. Now, as I said before, I'm going to do the aureole a little bit later, and I know from the cross section, sorry, the map, it cuts across F2. It isn't displayed, so I've got to show that relationship on the map, on my cross section as well. Okay, so next one is we've done F2. Now I'm going to extend it above the land surface, but I'm going to stop it at the unconformity because the unconformity cuts across it. So I've done that one there. So I've done F2. Now I need to do the folded layers. Now looking at the cross section and the map, I think I'm going to do this section first and then I'm going to do this one afterwards. So let's do this one over here. So no, one boundary is there for B, and that one goes up to here. So this is C, got B, A and B. Now I've got to work out from my map what's going underneath here, because we know something's going underneath the unconformity. Can't just stop at B under that area. So let's just go back. Right, I need to put in rock unit C below. So I'm going to use a different colour and I'm going to predict where the boundaries are. So I predict that that boundary will continue to this position here. So let's mark that on. Okay, so on this side I'd have rock unit C there, and it's tilted towards Y at 40 degrees. So I've got all the information that I need. Transfer that on. So the boundary would be there. I've got rock unit C here. Right, so got two fold axes. I'll put this, we'll start this way and head towards X. So this one's 40, this one's 40, but this one here is vertical. So let's put those in first. 40 degrees towards Y. Stopped by the unconformity. Okay, so that's one limb put in. So I've done those two here. So this B, the BA boundary and the BC boundary is vertical. So I don't move tractor for that one. Now, notice I'm not taking it too far down because I don't know how far down it's going to go. Well, let's gather some more information from the cross section. This is the CB boundary here, and this is the CB boundary there. So these two boundaries should meet up, so I can extend this one down a little bit further, take this one across so that they can join up. So we have the synform which is being predicted from the map here. So let's take that one down. Now we can take this back up again towards the fold to finish off the fold. We know how thick B should be because we've got the vertical cross dip here. So the outcrop width and the true thickness of the layer and the outcrop width are exactly the same. So it's just about 1 centimetre. So let's put the boundary in here. Centimetre, 2 dots further away from each other, and we can finish off the fold. And it just goes off the cross section. in this area there. So C sits above B, B sits above A, so we've got A here. Let's draw in our fold axis. In fact, I want to make this, finish this off so I know where it's going to be. There we go. So there's our fold axis. I'm going to continue it to get stopped by the fault. There's our synform in here. If I take this across at the same angle, because I've got the same dips on the limbs on either side, my fold axis is going to be somewhere in here at that angle there. So I've drawn this part of the section. So all I need to do now is finish off this area here. I don't need to go over this side because E is there. So let's line this up again. Both those here are dipping 40 degrees towards Y. That's rock unit C in this area. I've got B in here. Again, it's dipping 40 degrees towards Y. And underneath B is A. Right, so last bit I need to put in is the metamorphic aureole, and then there's no fault displacements. So metamorphic aureole occurs here. Okay, it's got to be the same angle as the boundary I've put in for rock unit E, the Pluton, because it's the heat that's conducted from the intrusion itself. It's managed to reach a set distance out, which is there. Now I'm going to continue this across F2. I'll explain why in a second. Remember on the map up here, the metamorphic aureole hasn't been displaced by F2. So I've taken it across F2 because metamorphic aureole, i.e. the Pluton, is younger than F2. And the last bit I need to do is to show fault movement. B is higher on this side compared to this side, so this side has gone up, this side has gone down. So it's down thrown toward on the eastern side of the fault, or position Y. And in fact, if we go back to the map, we can see here this little cross mark that we've got tells us that this side has gone down relative to this side. So cross section is finished.